One way in which solving equations and solving inequalities is different is that sometimes with inequalities you may have to flip the inequality symbol. And this happens when you multiply or divide by negative numbers. This doesn't happen when you're solving an equation. For example, if you want to solve the equation 2x equals 8, you simply divide both sides by 2. They cancel on the left, and that gives us x is equal to 4. You do the same thing even if the number in front of x is negative. So if we want to solve the equation negative 2x equals 6, we divide both sides by negative 2. They cancel on the left, and we get x is equal to negative 3. Now let's look at some inequalities that are similar to this. What if we wanted to solve 2x is less than 8? We would do this much like you would solve the equation. We would divide both sides of the inequality by 2. They cancel on the left, and we get x is less than 4. However, when you're dealing with a negative number, you have to be careful. Let's say we wanted to solve negative 2x is less than or equal to 6. Here, you can't simply divide both sides by negative 2 and be done with it. You have to be careful because when you're dividing or multiplying by negative numbers, you have to flip the inequality sign. So, if we want to divide both sides by negative 2, we're dividing by a negative, so we have to flip the inequality symbol. They cancel on the left, and we have x is greater than or equal to negative 3. This is one of the big differences between inequalities and equations, and that is if you're multiplying or dividing both sides by a negative number, you have to flip the symbol. So today what I would like to do is to really focus on why this is the case, because you don't simply just want to memorize the rule. Ideally, you want to understand this on a level so that the rule simply just makes sense to you. To get started, let's compare two positive numbers. And to help you visualize this, let me draw a real number line. And let me say that 0 is here. The two numbers we're going to compare are 6 and 12. Let's say 6 is here and 12 is here. And one thing I'm going to do to help you just quickly visualize what's happening is I'm going to draw a square around 6 and a circle around 12. Also, I'm going to call whatever number is in the square A and whatever number is in the circle B. This may seem a little unusual, but as we work through these examples, I think you'll see why I did this. So in this example, we have A is less than B. That's because 6 is less than 12, or 6 is to the left of 12. Let's see what happens if we multiply these numbers by 2. Let me draw another number line, and let's say 0 is in the same place. Now, I'm not going to draw this at the same scale at the top because then the numbers would be way off to the right. So if we multiply A by 2, if we multiply 6 by 2, we get 12. Let me just draw it here. And if we double 12, we get 24. And like above, I'm going to draw a square around the first number and a circle around the second. Now here, once again, A is less than B. Because even though we changed the numbers, we doubled them both, the order is preserved. A was less than 12 on the top, and after we multiply them by the same positive number, A is still less than B. Next, let's multiply the original numbers at the top by 1/3. Once again, I will draw a real number line, and we have 0 here. So if you multiply 6 by 1/3, 6 divided by 3, and we get 2. Let me draw that here, and draw a square around it. And if you multiply 12 by 1/3, you get 4. That would be here. So we have 4 here. And once again, just like at the top and in the middle, we have A is less than B. The idea is this. If you multiply A and B, the numbers in the square and the circle, if you multiply them by a positive number, the order is preserved. Now, what I'd also like you to do is imagine what if you multiply it by 1,000, or what if you multiply it by 0.001? And when you imagine what would happen and how these numbers would move around on the real number line, I want you to kind of convince yourself that no matter what positive number you multiply them by, A will always be less than B. Now let's see what happens if we multiply them by negative numbers. First, we'll multiply the numbers by -1/2. Let me draw another number line so that we can see where the numbers end up this time. Here, I'll put 0 over here. because we'll need room on the left. If you multiply 6 by -1/2, you get -3. So this is where a ends up after you multiply by -1/2. Next, if you multiply 12 by -1/2, you get -6. And this is the circle number, and we call this one b. In this case, both numbers, a and b, when we multiplied them by a negative number, they flipped sides, meaning they went from the positive half to the negative half of the real number line. And initially, a was less than b, but now a is greater than b. And that's because now a lies to the right of b. At the top, a lies to the left of b, but after multiplying them by a negative number, they flipped over the number 0. They flipped from the positive side to the negative side. And in doing so, b went from being to the right of a to b being to the left of a. To see this one more time, we're going to now multiply the numbers, the original numbers at the top, by -3. So if we multiply a, which at the top is 6, by -3, we get -18. I'll put that here, and this goes inside a box. Now if you multiply b by -3, you get -36. And this is the circle number, which we're calling b. So in this case, b is less than a, or you could write it as a is greater than b. They both say the same thing. The important takeaway is that at the top, a was less than b, a was to the left of b, but after multiplying by another negative number, they flipped over a mirror image over the number 0 from the right side to the left side, and now they also switched order. The order has changed. So you can write that as a greater than b, or you can write that as b less than a. But if you write it as a greater than b, then it's easy to see what happened is that the inequality symbol flipped. It went from being less than to greater than. Let's see another example. Previously, we saw what happened with two positive numbers. This time we're going to mix it up a little bit, and we're going to look at one positive and one negative number. And the two numbers we're going to work with are -5, which, like before, we'll put a square around and call it a. Let's say 0 is here. And then the other number is going to be 2. Circle around that, and this one is b. So in this setup, a is less than b. A lies to the left of b. What we're going to do is, once again, we're going to multiply it by a positive number, then we're going to multiply it by a negative number to see what happens. Let's say we multiply these numbers by 1/2. I'll keep 0 in the same place for this. If we multiply -5 by 1/2, we get -2.5, which goes right here. Now if we multiply 2, if we multiply b by 1/2, we get 1. That would go here. And a is still less than b. So when we multiplied by a positive number, in this case it was 1/2, so both a and b got closer to 0, but the order of a and b is preserved. The order doesn't change. A was to the left of b, and even though they both get closer to the origin, a is still to the left of b. And you can see the similar thing happens if we multiply by a number larger than 1, so they get further away from 0. Let's say we multiply by 3. We're multiplying the numbers at the top. So if you multiply -5 by 3, you get -15. I'll put that all the way over here. If you multiply b by 3, you get 6. Let's put that here. And in this case, a is still less than b. Here, because we multiplied by a number that was larger than 1, both a and b got further away from the origin. And because a was negative, it went further left, and because b was positive, it went further right. But what I want to really point out to you is that a was to the left of b before we multiplied, and after we multiplied by a positive number, a was still to the left of b. Now let's see what happens if we multiply these by negative numbers. First, let's multiply both numbers by -1/2. If you multiply -5 by -1/2, you get +2.5. And once again, I'm using a different scale for each real number line. Next, if we multiplied 2 by -1/2, we get -1. And because we multiplied these numbers by a negative number, they both changed sides. And when I'm talking about sides, the right side is the positive part of the real number line, and the left side is the negative part of the real number line. So initially a was to the left of b, but because we multiplied by a -1/2, they switched signs. and then the 1/2 brought them both closer to the origin. And the net result is now a is larger than b. Next, let's multiply these by -3. Like previously, we're multiplying the original numbers, -5 and 2. If you multiply -5 by -3, you get 15. Let me put that all the way over here. And if we multiply 2 by -3, we get -6. The result of this was they once again swapped signs. A went from being negative to positive, and B went from being positive to negative, and then they got further away from the origin. And so here, like above, A is now greater than B. So when you multiply real numbers by a negative number, it will change signs and either get closer to 0 or further away from 0, depending on if the absolute part is less than 1 or larger than 1. And for a final example, let's look at two negative numbers. The two numbers we're going to look at are -8 and -3, and 0 will be somewhere around there. First, we're going to multiply these numbers by positive numbers. Let's see what happens when we multiply by 1/3. 1/3 is less than 1, and so the numbers will end up getting closer to the origin. But because 1/3 is not negative, the signs for A and B won't change. So if you multiply -3 by 1/3, you get -1. And if you multiply -8 by 1/3, you get -2.6 repeating. So both A and B got closer to 0, but they kept their signs. And so while A is less than B in our original number line, after multiplying these numbers by 1/3, A is still less than B. It's because A still lies to the left of B. Next, let's multiply by 5. If you multiply -8 by 5, you get -40. And if you multiply -3 by 5, you get -15. So now, both A and B got further away from 0, but their relative positions are the same. A was to the left of B before, and after multiplying, A is still to the left of B. So A is less than B. So like in the previous two examples, whether or not you're working with two positive numbers, one positive, one negative, here we're working with two negative numbers. When you multiply these numbers by a positive number, their order relative to each other does not change, but their distance to 0 will. And finally, let's see what happens when we multiply with negative numbers. First, let's multiply these by -1. If you multiply -8 by -1, you get +8. And if you multiply -3 by -1, you get +3. So here, the distance from 0 didn't change. The only thing that did change was their signs. And because of that, while A was to the left of B at the top, now they've changed order. Now B is to the left of A. And we can write that as saying A is greater than B. And lastly, let's multiply the original numbers by -2. If we multiply -8 by -2, remember we're looking at the original numbers at the top, we get +16. So the number A not only changed sides, went from being negative to positive, but it also got twice as far away from 0 because the absolute value of -2 is 2. The absolute value tells you how much the number is either getting closer to or further away from 0. Next, let's look at the number B. If we multiply -3 by -2, we get +6. So once again, it changed signs and got twice as far away from 0. And so A and B went from being A to the left of B to now A to the right of B. And we can write that as A is greater than B. So in both cases, when we multiply the original numbers by a negative number, the signs change and the order changes. And when you're solving inequalities, that's the main thing to focus on. You need to understand at what point do the signs change. And so to symbol, if you multiply both sides by a negative number, flip the symbol. Otherwise, the symbol stays the same.